Dear students, let us solve a problem from complex numbers. The question is, if Z1 and Z2 are two non-zero complex numbers such that absolute value of Z1 plus Z2 is equal to absolute value of Z1 plus absolute value of Z2. Then argument of Z1 minus argument of Z2 equals to. Choices are given and we have to find the correct answer. Let Z1 is equal to R1 cos theta 1 plus I R1 sin theta 1. And Z2 is equal to R2 cos theta 2 plus I R2 sin theta 2. Then Z1 plus Z2 whole mod is equal to R1 cos theta 1 plus R2 cos theta 2 whole square plus R1 sin theta 1 plus R2 sin theta 2 whole square. Here after addition the real part will be R1 cos theta 1 plus R2 cos theta 2 and the imaginary part will be R1 sin theta 1 plus R2 sin theta 2 whole square whole root over. This is equals to. Here it will be R1 square cos square theta 1, R1 square sin square theta 1. So it will be R1 square. Similarly, will be R2 square cos square theta 2. This one will be R2 square sin square theta 2. So it will be R2 square. Then 2 R1 R2 cos theta 1 cos theta 2 plus sin theta 1 sin theta 2 whole root over. This is equals to R1 square plus R2 square 2 R1 R2 cos of theta 1 minus theta 2. Because cos theta 1 minus theta 2 equals to cos theta 1 cos theta 2 plus sin theta 1 sin theta 2 whole root over. This will be equals to R1 square plus R2 square plus 2 R1 R2 whole root over if cos theta 1 minus theta 2 is equal to 1. This implies theta 1 minus theta 2 is equal to 0. So here it will be R1 plus R2 whole square whole root over. This is equals to R1 plus R2 which is equal to mod Z1 plus mod Z2. Now theta 1 minus theta 2 is equal to 0. This implies argument of Z1 minus argument of Z2 is equal to 0. So bit C is the correct answer. So bit C is the correct answer. So here the question is Z1 plus Z2 whole absolute value is equal to Z1 absolute value plus Z2 absolute value. So first of all, we have taken Z1 is equal to R1 cos theta 1 plus IR1 sin theta 1. Z2 is equal to R2 cos theta 2 plus IR2 sin theta 2. Now Z1 plus Z2 whole absolute value will be, after addition Z1 plus Z2, real part square plus complex part square. That is R1 cos theta 1 plus R2 cos theta 2 whole square plus R1 sin theta 1 plus R2 sin theta 2 whole square. This is real part, this is imaginary part. After expansion, it will be R1 square cos square theta 1. Here it is R1 square sin square theta 1. Taking R1 square common, we get it is 1. Cos square theta 1 plus sin square theta 1, 1. Similarly, we get here R2 square. Then plus 2R1, R2, taking common, we get cos theta 1 cos theta 2 plus sin theta 1 sin theta 2, which is equal to cos of theta 1 minus theta 2. If cos theta 1 minus theta 2 will be 1, then this expression will be equal to this expression. That means if we know cos 0 is equal to 1, so theta 1 minus theta 2 is equal to 0. In that case, this one will be R1 plus R2 whole square whole root over, which is R1 plus R2. And we know R1 means mod Z1 plus R2 means mod Z2. The condition here is given Z1 plus Z2 mod is equal to Z1 mod plus Z2 mod. So in that case, we are getting theta 1 minus theta 2 is equal to 0. It means argument of Z1 minus argument of Z2 is equal to 0. So bit C is the correct answer. With this, the topic for this class is completed. I shall meet you soon with a new topic. Till then, goodbye.